All right. I want to welcome all of you to our PolarConnect event for June 20th, 2017. Almost summer solstice time, but just a day off. We're excited to be talking with a team that is in Greenland. They are at Summit Station, which we're going to hear more about, and we're going to hear about their work, which we call the dynamic observations of the microstructural evolution of Firn. Can't wait to hear what all that is about. We have Steve Kirsche, and I'll let him introduce his team here in a little bit. But before we get started, today Judy and myself, Janet, we work with ARCUS, and we'll be hosting and facilitating this presentation. It is being recorded so that if you have to bug out early or you want to share with somebody, we'll have an archive in a couple of days that you will post on the website, as well as send out by email to those that have registered, and you can preview the archive. A few things about our platform that we're using. It's called Adobe Connect. As you can see, it does have a webcam feature, and today the webcam feature is just going to be used with the presenters from Summit Station, Greenland. The rest of us will just get to see them, and we should be seeing slides in the center of your screen there. There is a chat feature, so if you have questions as we go along, you can feel free to type them in the chat area, and we will relay those questions to the team so they can answer them. There's also a list of participants, so you can kind of see who's joining us as well. If the webcam slows down their bandwidth too much, we might have the team turn it off so that we can hear them better, but otherwise we hope that we can see them for a while. And I think that's it. Let's see. If you haven't done so already, we want to have you introduce yourself, so please put your name, and if you're with other adults or kids or in an institution someplace, please share that with us. And again, as we go through, just use the public chat area for those questions and responses. We hope at the very end of this presentation you all have microphone access and that you might be able to ask your questions live. A quick introduction about what is PolarTREC. So PolarTREC is a program that is hosted by a nonprofit, the Arctic Research Consortium of the United States, or ARCUS for short. We're based in Fairbanks, Alaska, with an office in Washington, D.C. We're a team of professionals that works with scientists from around the world. And one of the programs that we have is this PolarTREC program, and it's funded by the National Science Foundation. And for over a decade, we've been placing teachers like Steve with researchers like Ian out in the field and in the polar regions, and hoping that not only do they learn about polar science, but also that they bring that science back into the classroom that they're teaching it. And we do place teachers in the Arctic and the Antarctic, and we're really excited because we've just kind of started our Arctic season, and we have teachers, 2 teachers that just came back from expeditions, and Steve is just about to wrap up his expedition, and throughout the summer we'll have other teachers headed out to the Arctic, and then teachers headed with researchers to Antarctic starting in the fall. So great program, and we love placing teachers with scientists. This is just a little, again, a preview of how to do your questions. At the moment, just type them in the chat box, and at the end we'll explain how you can ask them live. All right, so with that, I'm going to turn this over to you, Steve, for you to introduce us to your team.
All right, thank you, Janet. My name is Steve Kirsche. I am a science teacher from Florida. I teach at Liberty Pines Academy in St. John's, which is right next to Jacksonville. And I was lucky enough to get to accompany Dr. Baker and Eric Wagner on the trip, so I'll let them introduce themselves real quick. Eric?
Hey, I'm Eric Wagner. I'm a PhD candidate at the Thayer School of Engineering at Dartmouth College. This is the project that I'm working on with the dynamic impact of Firn.
Hi, I'm Ian Baker. I'm a professor at the Thayer School of Engineering and PI on this project.
Okay, so just a little bit about where we are and what we're doing. It's kind of what we're going to talk about today. So first off, we'll kind of just go over a little bit about Greenland itself. Greenland is a territory of Denmark. It has some self-rule, but it still falls under Denmark. Geographically, it is part of North America, and it's one of the largest. It's the largest island in North America. And even though it's a fairly large country, it's about 1/5 the size of the United States. There are not a lot of people that live here. And as you can see in the picture on the slide here, the ice sheet covers most of it. We're actually located at Summit Station, which is on the picture on the left there. The little red dot shows where it is, and it is right in the middle of the ice sheet. Where we are, there's about 2 miles of ice beneath us, and we're on the top of that. And it kind of spreads out towards the coasts where the melting that you hear about is happening. Summit Station has been here since 1989. It was started for a ice drilling project called GISP-2, and since then has been continuously in use, and it's run by the National Science Foundation. And then the picture on the right kind of gives you a Google Maps image of it, which is kind of hard to tell much from. But coming up here to Summit Station was actually a lot of fun. We flew on an LC-130 airplane. It's the Air National Guard group in Scotia, New York, has these planes. As you can see in the picture here, they have skis as well as wheels. And so they're able to take off from Scotia on a regular runway. And then when they get up here, the skis allow them to land on the snow. And so that's the main way of coming in and out. There are other planes, the Twin Otters that come from Iceland. That was a very small plane. They get in and out of here as well. But besides that, there's not really any other way to get here. We're about 250 to 300 miles away from anything else. Up here on Summit Station, it's the picture on the bottom shows you a view of it. We are in the big house, which is the one all the way on the left with the big dome on top of it. That's the radar. That's sort of the hub of the station. That's where people go to eat. That's where people go to hang out, watch movies, meetings, all that sort of stuff sort of happens there. If you go to the right a little bit in there, there's a building called the Greenhouse. That's sort of where a lot of people live birthing-wise. Yep, that one right there, where the arrow is pointing to. And that's also really important because in the winter, they'll have about 5 people on station here, and they winter over. And as you can imagine, the weather up here gets really bad during the winter. They'll get 60, 70 degrees below zero, with wind chills much lower than that. So the greenhouse is a place where they can sort of hunker down. It has an emergency kitchen, and so they can use it for that. The rest of what you see over in that picture is there's a garage. There's a lot of little buildings where they have carpenter shops and birthing modules and things like that. And then over on the right is what we call Tent City. You can see the Arctic Oven tent is the top left picture on the slide. That's where most of our team is staying while we're here. It's actually warmer than you'd think. I know if you wake up in the morning and it's about 5 to 10 degrees below zero, inside your tent it's a nice balmy 20 degrees or so. So you kind of get used to it. But that's a little bit about Summit Station. Right now there's 42 people on station here. That includes the 5 from our team and 7 that came in from the other team. So 30 is probably a more reasonable number for what we'd expect up here this time of year. But the teams obviously make it bigger. The whole purpose of Summit Station really is to do science. There's a lot of long-term science projects that they do up here with monitoring the weather, monitoring the snowfall, the radiation, that how much the sun puts in and how much gets reflected back. All that's constantly going on, plus teams that sort of come in and out like we are. So when we talk about an ice sheet, there's actually 2 ice sheets in the world. One is up here on Greenland, and one is down in Antarctica. And you can see from the slide that basically if you have 20,000 square meters or more than the covered of land, then you are an ice sheet. And 99% of all the freshwater ice is on those two ice sheets. And with the changes that are happening with the melting in both ice sheets, it's very important that we study them. We learn what's going on with them. Why is the melting happening? How fast is it happening? So we can determine the impact that it might have on the rest of the world. One of the best ways we do that is by drilling into the ice. And so we'll talk more about that because that's part of what our project's going to be. Big aspect of what we're talking about is we're talking about stuff called firn. And firn is essentially old snow that hasn't turned into ice yet. Because up here at Summit Station, when it snows, the snow doesn't melt. It just keeps piling up more and more. And as it does, it gets compacted more and more. So at the top, the temperature affects it a little bit, but then as it goes down, the pressure is going to keep piling it up, and it's going to turn it into firn. So when we talk about firn compaction, I'm going to have Eric move a little closer here and tell you a little bit about firn compaction.
Hi. So when we talk about firn compaction, we're talking about the snow turning into firn, turning into ice. So as the snow falls, it's pretty light, it's pretty fluffy, not very dense. But then as it gets buried and the depth increases, it compacts into firn, and then that firn compacts into ice. And on the surface, you would imagine that the temperature gradient is the biggest factor. The sun's beating down on the ice sheet. It's going to make it hot on top, well, relatively, and then cold on the bottom. So that's going to be driving the changes in the snow turning into firn, turning into ice. Then deeper, you have that overpressure of all the snow and ice above the little piece of firn you're talking about. And that's really what compacts it down and eventually turns it into glacial ice. And in Greenland, when we talk about changing into ice, we're talking about a depth of 80 meters, which is where the pores or airspace in the ice actually close off. So you get those just little not connected air bubbles that you can date the atmosphere from, and etc. So we know that snow turns into firn and that turns into ice. That's not really what we're studying here because we already know that. What we were studying here is what would happen if we take some of that firn, which we collected here in Greenland, and then we actually apply that temperature gradient or that pressure and study how the microstructure actually changes when you apply those different external experiments. So to do this, we drilled some ice core samples down to a depth of 80 meters, and then we're going to take those samples back to Dartmouth and do some experiments on them.
All right, so for the actual drilling that we're doing, we have a site that's about 6 kilometers away from Summit Station. And I know it's kind of hard to tell from this picture, but just for scale, you can see over on the right is Summit Station. And we take a snowmobile each day that we're going out there to go to our drilling site. And we travel, as I said, as a crow flies, it's about 6 kilometers. We have to go around because there's a lot of different areas that are protected, where they monitor the snow accumulations, and they have places that people can go in and do experiments. And so we have to stay well away from them, so we go quite a ways around to get there. But this kind of shows you the drilling site that we used. The big picture on the top left, that tent covers the drill itself. That's something they were experimenting with this time because it helps protect them from the weather. We did have a couple of days with some bad weather, and that kept the drill so they could still do that. And then, the other pictures there just show you a few of the things while we were there. While we're there, what we're really collecting are what we call ice core samples. And you can see there's a picture of one there. And it's very hard to see in that picture, but that particular one has a layer that's darker than the rest that indicates a melt that happened back around 1879. But we drill those out, and the deeper we go, obviously the older the ice gets, and we're going to transport all those back so that we'll be able to study them. To get the ice core sample, we actually have two professional drillers that are up here working with our team, and they have a hollow drill that they drill down in. It chips away the ice around the core sample itself. Those chips collect in a cup, and then the core gets captured inside the middle of the drills, and then they pull it back up, and we get the piece of ice out of it. We did that over and over again for, I think we had about 86 or 87 ice cores to get us down to 80 meters. And all those are what we're going to bring back with us. Hopefully this video will work. Just a real quick video to sort of show you how the drilling process works. So we'll try it and see if that video works.
Yeah. Okay, just a second. Before we go into the video, there was a question that maybe Eric or Ian can answer from Courtney about what initial question did you have that led you or your team to this research?
Yeah, so this is Ian. So what we're trying to understand is the fundamental physics of the Firn compaction process, so that we can understand how the structure of the underlying ice forms and how the air bubbles form in that ice. And it's the air bubbles in the ice that actually enable researchers to reconstruct paleoclimate.
Okay, great, thanks. All right, let me get started on this video. I have no idea what's going to happen in your land up there in Greenland, so just stay with us. It may be kind of crazy. So, all right, let me know, Judy, can you see a screen that says video on it?
Yes.
Okay, there we go. Oops, audio, sorry. Can you hear it?
Just really lightly. Can you turn it up?
Has been started already, and when we bring the core up, we send it out the door, and then put the whole thing back together again in its horizontal position, and then invert it vertical, go back down the borehole.
I don't know if it's just us, Janet, but we're not getting much on this.
You probably are not getting it because of the bandwidth. Anybody else, Judy? You can see if anybody else is having issues.
Yep. Well, we've lost the chat area because the video is taken over. So.
Oh, yeah. If you're listening and can hear me, if you're having or not seeing this video, don't worry. We'll make sure that you have the link to the final version as well. Steve is creating a movie about it. You can talk, Steve, about the things if you don't want to just rely on the audio.
Okay. Don't know how it's coming through for everybody else. It's very choppy watching it up here, but if you can see the video, the drill that they have, you can see right there is the core sample that's captured inside it. And then they take the drill barrel out. They push through it to get the core out to us so that we can get it ready to go back to Dartmouth. There's another example of a core sample.
Hold on, I'm trying to get back to my sharing. Okay.
Okay. The video that was supposed to play, and again, I don't know if it came through for others. It was very, very choppy up here. It will be on the PolarTREC YouTube channel. It's actually part of a larger video that will be uploaded once we get back. The bandwidth up here is not really good enough to upload videos very well. So you can watch it, plus we'll give you a little bit more information about how they set up. But that's how they get the drill ice core samples. Once they pull it up with the drill, then they can push that through to us as they showed towards the end. You can see the two pictures there. The one on the left is where they have a big long pole that they push the ice core sample out with. And then on the right, we have it on the table where we measure it and log it. Each one that comes up is put in the logbook so that later on when they want to go back and study it, they can tell exactly the order they go in. Plus it gives us a very good record of how deep we've gone. And then the biggest thing once we get it logged is we have to get it safely back to Dartmouth. You can imagine that's a long trip to get from here to there. So what we do is that we have some plastic tubing that we wrap it in. We put it in an insulated tube and then into a very heavily insulated box. You can see on the picture there on the sled, there's 3 of the boxes that are loaded up. Each box that we filled has about 6 ice core samples. So that's about 6 meters. And they weigh about 150 pounds per box because we pack them with snow, since water is a very good insulator and will help keep them from melting on the way back. Once we got them on the sled, we brought them back to Summit Station. And here they have a really cool underground storage place where they keep their food. And that's where we put our boxes because the temperature down there is about 40 degrees below zero and was cold enough for our samples to be kept. So once we're ready to leave, we're actually going to be flying out of here back to Kangerlussuaq on Friday. We're going to have to pull all 15 of those boxes back up. They're going to be loaded up onto the C-130 where we'll fly back to Kanger on what's called a cold deck flight, where they'll keep it very, very cold in the airplane. We'll be very well bundled up for that, and then they'll be put into cold storage there. They'll take another cold deck flight back to Scotia, New York. Once they're there, they'll be put onto a refrigerated truck and brought back to New Hampshire, where Dartmouth is located, to be kept until they want to study them. As far as contamination of the core, we're not quite as careful as other teams that work with ice core samples because we're not really looking at the chemistry of it. They're more interested in the physical properties. We did wear nitrile gloves, which are like plastic gloves that covered our own gloves while we handled them, just to keep them as clean as possible. But it wasn't a huge concern for this particular project. Again, once we get back to Scotia, which should be on the 29th, they'll all be loaded into what will hopefully be a waiting refrigerated truck, and they'll be stored. And over the next few years, Eric, that's his PhD project, as he mentioned, will be working with Ian supervising him. And they're going to be looking at the structure using 2 different pieces of equipment. One of them is what's called a micro CT, which is essentially a machine that uses X-rays to look at the structure. It's similar to a CAT scan that you use on human beings. They'll also be using an SEM, which is a scanning electron microscope, to look at the structure. Those will give you the structure in different scales. So they'll be using both of those to take a look at them. And as Eric alluded to before, they're going to be taking the ones from closer to the surface and putting a temperature gradient on it and seeing how it changes. The ones that are lower down, because once you get lower, the temperature would be very much steady and you wouldn't have a gradient. They have a machine that can actually put them under pressure, and then they can look and see how does that pressure change the structure. Before, when Ian was talking, he mentioned a little bit about paleoclimatology. That's actually one of the most important reasons that we study ice core samples. The ones that we're studying, that they're bringing back and they're going to be looking at, they're really not going to be looking too much at the paleoclimatology on those because they're studying down to the point where the bubbles in the ice get closed. Once they get closed, then the air that was in them will be there forever. So what's so important about that is if you go down, say, 200 meters or 1 kilometer, then you can get the air back out of those bubbles, and it's air from the past. So if you want to see what the atmosphere was like in the past, it's one of the only ways, probably the only way, that you can actually get direct evidence. You can get samples of that air. And so that's what paleoclimatology does for us, and what a lot of people study with the ice core samples. As far as what they're hoping to learn, I'm going to turn it over to Ian on that.
So what we're trying to understand is the fundamental mechanisms by which the Firn undergoes compaction. And there's many different ways that can happen. So at the surface, as Eric mentioned earlier, there's a temperature gradient, and what that temperature gradient does is produce a vapor pressure gradient, and that vapor pressure gradient leads to water vapor moving from the warmer area to a colder area, and so you get changes in the ice because of that. When you lower down, what happens is there's a variety of mechanisms by which the ice can deform. It can sinter together, it can undergo what's called plastic or permanent deformation, and all that leads to eventually the pores being closed off in the ice. And hopefully when we understand those processes more, we can actually model it. So we can actually model how the Firn column changes into ice, so we can understand how those pores eventually get incorporated into forming air bubbles in the ice.
Yeah, so can I?
Okay, so that's it for our presentation.
There were some questions.
Take questions.
So perfect timing. So going back up to a few. So you answered the one with the contamination. Let's see. There was a question about how much room does Dartmouth have to store the ice cores, and I guess related to that is, do they always stay at Dartmouth, or do they go somewhere else later?
So basically, we really don't have much storage at Dartmouth for ice cores, and these particular cores are going to be stored at the U.S. Army's Cold Regions Research and Engineering Laboratories, which is about a mile away from the engineering school. And so we just access the
cores as we need. And that related to that, I guess, is how long does an ice core last? Is it infinite amount of time or in storage?
No, it isn't really infinite, because they're going to be stored at about -20. So it's important that we look at the core near the top, where any changes are going to happen most rapidly to the core, because there the microstructure is the least dense. So they definitely don't last forever. We don't really know how long they will last in a usable condition, but certainly they will be changing with time, just as the Firn actually in the ice sheet changes with time as well. So that's sort of, there's no real way you can stop the cores from changing.
A question that came up from Maureen, are the cores used by other scientists?
We don't have any plans for these cores to be used by others at this particular time, but we're probably not going to use all the material in the core. The size of the sample for the micro CT unit that we use is about 20 millimeters in diameter by about 70 millimeters high, and the core that we drill is about 75 millimeters across. So you can see that even at one level we could get many samples, and if we were to make a sample over every length of core, it would take us tens of years to actually go through the whole core using our technique. So we only sample certain depths in the core. So there is material that's left over that could be used by others.
There was a question also about, I think it was Steve that said something about that you can use them for paleoclimate. How far back in time do you estimate these cores represent, I guess?
Well, this particular core that only goes down to 80 meters only goes back about 260 years or so, something like that. So these aren't that. These don't go that far back in time.
All right, and if anybody else, go ahead.
But again, as Steve said, the ice does go a lot deeper than that. In fact, it's about 2 miles. So deeper ice drilling, such as the GISP-2 that happened here, can go hundreds of thousands of years back.
Let's see, another question. Are you seeing changes in the ice sheet due to warming?
Well, we haven't seen anything this year, but when I was last here in 2012, that was the year that there was a general melt over the whole ice sheet. And that melt is actually incorporated in the ice sheet. So in the fern core that we've drilled, we actually saw 3 different melt layers. One was from 2012, one was from about 1879, and one was from about 100 years earlier than that. So so we do see those melting events, and if it's melted here at summit, which is right at the top of the ice sheet, it means that it's pretty much melted everywhere else on the ice sheet as well.
Okay. Anybody else have other questions? How deep do you have to drill to reach Firn hundreds of thousands of years ago?
Well, it isn't Firn when it's beyond 80 meters. It's actually, we've simply referred to as ice at that point with bubbles in. But as Eric mentioned, by the time you get down to the bottom of the ice sheet, you're looking at a couple of 100,000 years for the age of the ice.
I see another question coming up. You mentioned that the ice was about 2 miles deep. How old is that? And you might have just answered that while I was doing something, but go ahead and reiterate it.
Yeah, I think it's I don't remember exactly, but it's about 200,000 years or so for the ice in Greenland. They've actually gone about the same depth in Antarctica, but the accumulation levels at some places are actually much less in Antarctica. So when you get to the same depth in Antarctica, you're actually going back to a much older period of history.
Very cool. Anybody else have questions? Waiting to see. There is some people that joined by phone. If you joined by phone, I muted you, so you have to *6 to unmute if you have a question. Anybody else? Somebody's typing. So what is your plan here for when you're going back to Dartmouth? I know Steve mentioned it, so what's the plan?
Yeah, we're actually here at Summit Station until Friday, the 23rd. So about 3 or 4 days from now, we're going to fly back to Kangerlussuaq, which is on the western coast, much further south in Greenland. There, they'll be storing the ice cores for about 6 days until the 29th. The 29th is when the flight back to the United States will be. There's a couple of C-130s that are going to be going back, so one of them will be house all the ice core samples. As I mentioned a little bit before, we have about 15 boxes, which is about a ton of ice. The other team that's up here has 23 boxes, so they have about 1.5 tons of ice. So all of that ice will be put on one of the C-130s, and they'll be going back cold deck, which means it'll be about -20 to -40 degrees on that plane. The rest of us hopefully will be on a warmer plane, flying back at the same time. So they'll all be back on the 29th of June.
I don't know if I'd want to be the person that had to go on that cold airplane. It's a long ride to be so cold.
Well, I will say this morning with the trip I was going to say this morning, the trip I did with the on the Twin Otter, we actually came back on that cold deck, and I will tell you, it was a very cold 1.5-hour flight, so I can't imagine 6 hours of it.
All right, so Sam wanted to know, it's a big ice sheet. Why have you chosen to work at Summit?
Yeah, so the reason is that really it's really the most convenient place here. So there's a camp, the station here, the National Science Foundation station, actually at Summit. So that makes it relatively easy for us because the LC-130 flies into here. We can actually stay at the camp, have meals at the camp, even shower occasionally. And we then go out to our own drilling site, which is about 6 kilometers away. If we did it remotely, then it'd just be a lot more difficult to do. So it sort of didn't matter too much where we did it on the ice sheet, and this is sort of the easiest location to do it for us.
And let's see. Maureen wants to know how long will it take to drill to bedrock? Oh, and go ahead, Steve, whatever you want to add.
Yeah, no, actually, I was going to address Maureen's question. The GIFS project that they talked about, they actually drilled all the way down. That started in 1989 and finished in 1993. So it took them about a little over 3 seasons. Now, obviously, they wouldn't be drilling, 12 months out of the year, but for the summer season when they can come up here and drill, it took them that long to get all the way down to bedrock.
I'm waiting to see if there's anybody else that wants to ask a question here. I think we've done pretty good. While I'm waiting, I see Judy's typing. Just a reminder that this event is going to be archived, and you can get it from the website and also be sent out to all the participants that register. Your journals, Steve, have been great, and we look forward to seeing your movie that you're going to produce when you get a good internet connection, eventually upload. It'll be fun to see what that's like.
One thing to just kind of comment about when talking about life at Summit that Ian sort of alluded to, because I know from my own students back home before I left, they were kind of curious about that. We do get showers up here. They try to limit it to 2 showers a week and laundry 1 load a week, which may sound gross at first to only have 2 showers a week, but really you don't get all that dirty up here. There's no dust, no dirt, and you really don't sweat a lot.
No, probably the
nice
opposite.
Cool.
You're always trying to get warm. Okay. Let me see what Judy says. Yep, she says it's luxurious. Have any of you, Ian or Eric, have you ever been to Summit before, or was this your first time, or worked at other field stations like this?
I've not been at any other field stations like this. This is my first time out.
Yeah, I've actually been to Summit twice before with, we had a National Science Foundation sponsored program for graduate students where we brought up about 6 graduate students to Greenland for about a 5-week period. And as part of that, they came up to Summit Station for 5 or 6 days. So a couple of times I came up to Summit Station with them. And then the group, actually, those graduate students went on to see other parts of Greenland, go to the capital, study the flora and fauna of Greenland as well. And different faculty members from Dartmouth accompanied those students as they did different parts of Greenland.
All right. Yeah, it seems like a really nice, really luxurious station for sure. So a couple of other questions related to Steve. So when you get back to your school next year, what do you want to share? And what has been the best part of this experience so far?
All right, well, I'll do the second part of that first. The best part of this experience, I think by far, has been the people. It's been amazing meeting the people that work up here. They're just an incredible group. As I've gotten to know a lot of them, it seems like most of them work here, work in the Antarctic as well, and they just love what they're doing, and it's just a really nice group, and I've enjoyed spending time with them. As far as when I get back to the classroom, I want to be able to share with my students a little bit about what science is like out in the field. I think it's kind of easy as a science teacher to go in and teach the facts, teach how to do things, but to have some real world experience to talk about the glamorous parts of it when you're out digging a 2 meter snow pit, or lugging 150-pound boxes of ice cores. Let them understand that there's a whole lot to it. The other thing I want them to understand is hopefully to be able to share a little bit more about the polar regions. I know for me, teaching in Florida, not too many people down there really seem to care much about the polar region. And so I think to be able to, just tell them a little bit about it firsthand, I think will hopefully be useful. And as far as bringing a piece of the ice core back to Florida, I actually have I have some from the 80 meters that will obviously be liquid by the time I get there. But yes, I do have some that I'm bringing back.
So, yep, go ahead.
I see Tobias's question. Yeah, I was gonna say with Tobias's questions about their circadian rhythm and the lightness, it's definitely been interesting trying to sleep up here. In the Arctic ovens, they're made to let in as much energy from the sun as they can. So that also means that they stay very, very light. And so I found for me, I probably sleep less than normal, and I wake up a lot more often during the night. I tried the eye blinders, and it bothered me too much having them on my face. So I've just kind of been dealing with it. I get enough sleep. It's just you do it in smaller sections. I don't know how Ian and Eric feel about sleeping.
Yeah, I'm in an actual building, not in one of the tents, so it stays a little bit darker. But just to go on that, it's kind of like the atmosphere of the camp is pretty energized, and I'd say even if you didn't have too much light, there's a lot to do, so stay up to do it.
Yeah, I think the other thing to keep in mind as well is that we're actually 10,500 feet here, and we flew directly from sea level to this, and so it takes quite a while to get used to that, and so you sort of get a little more out of breath and that, and I think that also affects the way you sleep as well as it being light all the time.
Yeah, I can imagine. Well, actually, I know firsthand what you're going through. And I'm sure it's the opposite for those that overwinter there in the winter. They go into hibernation mode. All right, let me see. Okay. Let's see. I think we're okay with questions. Anybody else? Or while people are thinking, any last thoughts from the research team or things that you want to share?
Well, for me, I've been working on ice and snow and firn for about 30 years, and I've been up here a couple of times, but this is the first time I've actually gone out and drilled my own samples with people. So it was actually a pretty illuminating experience to see the whole drilling process take place, and some of the difficulties you run into, and the skill of the people who actually do this drilling as an occupation. It's something that I really sort of value tremendously after seeing what they do.
Yeah, I like to see just the cooperation and the amount of teamwork that it takes to keep a camp like this running. We have, it feels like a lot of people working, but when you think about how many jobs need to be done, and the fact that we pretty much have to do everything up here, it definitely takes a lot of working together. So that's always cool to see.
And I think for me, I feel very, very fortunate to have been able to take part in this, to be able to see everything from the drillers to the scientists. I know Dr. Baker gave a talk to the camp, sharing some of the science behind what we're doing, and just to see the interest level in that, and for me to try to understand it. It's
a
been
couple of
amazing.
questions that came in while you guys were chatting. Maureen, what do you want us to share with our students?
I think we've, as I sort of mentioned before, just to kind of understand that, there is, climate change happening, that the polar regions are very important. As I mentioned in the slideshow, I mean, 99% of all of the freshwater ice is captured in these two ice sheets that we have on the planet. And so it's important to kind of understand what's happening with them. And so, I think that's an important thing to bring back and to share with the students, but also to understand that when we look at data, it's easy to look at numbers, but to sometimes take that step back and figure out, well, where those numbers come from, to understand that to get the information they want from the ice core samples, someone has to get up here and do that. I mentioned the other team from Dartmouth that's here. I mean, they left out of here on May 6th on a bunch of snowmobiles, each towing about 3 sleds. They traveled around Greenland collecting samples and just got back in yesterday. So, just to think about the hard work that went into all that just to get the samples so that they could get the information.
Okay, and then a question for Ian. Will you be going back there in the next few years?
I don't have any plans at this particular point. I have other projects that I might be working on ice and snow, but some of those projects we make our own ice at Dartmouth as model ice, and also there's something called the National Ice Core Laboratory, which is in Denver, Colorado, where ice cores that have been drilled going back 30 or more years are stored, and if you want to work on that ice, you can actually request ice from that facility. So in the past, I've often obtained ice from that place to look at particular aspects of the deformation behavior and the microstructure of ice. So I don't have any immediate
Very
plans
good.
to come back.
Let's see. Anybody else with questions? All right. Well, I appreciate your time doing this presentation. It's been really interesting to hear all about the work that you're doing and what happens to ice cores once they leave the ice, and hear what Steve is going to be doing with this experience when he gets back to school. So thank you guys for taking the time out of your day. I know that time is important up there when you're collecting and getting ready to leave and doing your research. So we appreciate you sharing everything with us. And while we wrap up here, I pushed out a thank you slide. As we, again, want to thank the National Science Foundation for their support of sending teachers out with researchers. And there will be like I mentioned before, the archive will post that. And hopefully we'll have Steve's movie when he gets better connection to the rest of the world to share with you all. So anything else that the team wants to say? And then I'll stop the recording and let family and others say hello as well.
That's it for me.
I just want to thank the National Science Foundation and ARCIS for the chance to come up here. And thank you to Dr. Baker for including me on this expedition. And for everyone that came today to listen, appreciate that.